Hi everyone, Grant K here for the Flame Premium Learning channel. In the previous video, we looked at the fundamentals of projection in action. In this video, we'll take a 2D still and convert it into a 3D scene with projections. This means we can introduce camera moves, align the 3D environment, and this is all in keeping with the perspective of the 2D still. If you would like to follow along, please click the link in the YouTube description to download the media. Alternatively, if you're watching the podcast version of this video, then type the link displayed in your internet browser. Starting off in batch, I have loaded the media and set the batch duration to 50 frames. I have also added a new action node and loaded the setup that comes with the downloadable media. Use the Load Node button to load the setup. Just ensure you select the first media entry and extract it out to the batch schematic. The scooter and its mat need to be connected to the node. Looking at the action result with F4, we have a tracking shot of a scooter on a driveway. Originally, I wanted to shoot the scooter in the middle of the road, but for health and safety reasons, it was not possible. So I have this shot and a still of the road I'd like to use. Since this video is primarily about projections, the images have already been undistorted, and this shot has been 3D tracked with the Analyzer node. We're already looking through the tracked camera. Press F7 for the Analyzer 3D view to see the tracking data. If you look at the Analyzer menus, you can see the settings I have used to do the track. One important part of 3D tracking was to define a ground plane, which we will use for this example. Switch to the Display tab and enable the Grid XZ from the pull-down menu. When we place the floor projection, this will be integral to its alignment. Now going back to the result view and scrubbing the frames, you will notice tracking locators on the floor, scooter and fence. We'll use the locators on the floor and scooter for alignment, but the fence locator is just for a visual reference. So 3D tracking is required to work out the camera movement, parallax and other real-world properties. Now the idea is to replace the environment around the scooter and match the camera move. Let's go through the workflow to build a 3D environment to receive the projection. Let's use Alt-2 to set up a dual screen split. Place the result view on the right and the action schematic on the left. Locate the original image attached to the track camera and hide it with the H hotkey. Now swipe left to bring up the batch schematic. Let's use white frames as 3D objects that will eventually receive the projection. Drag out a color frame node. The default color should be white. Select the action node and press Ctrl N for a new media input. Connect the color frame to the red input and go back to the action dual view split. Scrubbing the time bar, you can see the surface moving with the camera movement. Now let's project the still image onto the white surface so that we can choose the exact portion of the still frame to be used in the final framing. Switch to the batch schematic. Select the action node and press Ctrl N for another media input. Connect the 5K still into the red input. Return to the dual view split with Alt-2 and delete the 5K still from the action schematic. In the Action Bin menu, select the still in the media list. Select the white surface object and apply the still as a diffuse map from the Action Node bin. Double-click on the diffuse map node and go to its texture controls. Currently, the still is wrapping around the surface object. Change the mapping to projection. Looking at the result view, the 5K image is projected through the current camera. Let's look at exactly what is to be included in the final frame. Switch to the Grid menu and enable Border and exit the menu. Looking at the content of the frame, you can gauge the size of the still. So there is lots of flexibility for framing the projection on the geometry. Double-click on the axis of the diffuse map. You can frame the projection however you want, but I would like to focus mostly on the road from a low angle to match the scooter. So set the Y position to 1200 and the X position to 1000. The reason for setting up the projection first is that it will help with aligning the geometry to the perspective of the projection. So if you were to alter the projection later on, remember you will also need to reposition your geometry to match the projection's perspective. This will become a lot clearer when we start building the 3D environment. Now that the projection is set up, let's use the surface object for the ground. Press space F4 for the working view. We will use this view and the top view to align the surfaces where necessary. Switch to the orbit mode and move around the view until you can see the surface object and the camera. Since the ground plane is correctly defined for the camera from the 3D tracking, we can match the surface object to the grid. Select the surface object and change its X rotation to -90. Orbiting the working view, you will see the surface object sitting exactly on the ground plane. You can turn the grid off through the Analyzer Display tab or go to the Node's Preferences. Under the Preferences tab, turn the grid off via the pull-down menu. You can also see that since the surface has been rotated to the camera, the projection now mimics how the camera would see the ground. If you quickly toggle to the result view, you can see that this still lines up perfectly. But now the ground plane is too short for the projection, so we need to stretch the surface object to receive more of the projection. Switch to the top view with Shift 4. So we're looking straight down onto the ground, and this view will eventually show us all the perspective we need to align. Select the surface object and scale it up above 200%. You can also shift the object in Z position so more surface area is affected by the projection. Now here are some interesting facts. Select the diffuse map and press F1 for its front view. This 5K still has completely different perspective to the original shot with the scooter. In terms of building the geometry in a 3D environment, we have already added the surface object as the floor. But now we need to add some more geometry to build up the rest of the scene and maintain the perspective. First, we will add a surface object as a backplate for the objects in the distance. And then we will build the surface objects for the pavement and houses on the left and the cars on the right. Switch to the top view with Shift 4. Go to the Action Bin menu and choose the white frame in the media list. Double-click to add it to the composite. You will see the outline in the top view. Now I want the backplate to start just after the white line in the road. So select the surface and move it back in Z space. Now rotate the Y value to angle the backplate towards the camera. Finally, scale it up over 350%. If you look at the working view with space F4, you can see that the surface is a good distance from the camera and we can see the two white lines on the ground. To make it a bit easier to see, you could raise the surface object in the Y position to meet the ground plane. To include the backplate into the projection, drag a connection from the image object to the axis of the projection. Orbiting the scene, you should notice how the 3D environment is coming together. Next, we'll do the pavement and the cars. Go to the Action Bin menu and add another white surface into the action schematic. This surface object will be for the pavement and its perspective. Switch to the top view with Shift 4. Now move the surface over to the pavement and rotate it to match the perspective angle created by the projection. I would also scale it up to just over 200%. Going back to the working view, you will see the angle of the surface lining up. Raise the surface in Y position to meet the ground. As before, connect the surface object to the axis of the projection to inherit its properties. We have one more surface object to build for the cars. Hold Ctrl and drag a box selection around the axis and the surface object for the pavement. Press Ctrl D to duplicate the node selection. Switch back to the top view. Select the axis of the surface object and move it over to the cars. Rotate the object in Y to match the cars. Once you are done, connect the surface to the projection. Press space F4 for the working view. You can toggle the wireframes on and off with the I hotkey. When you orbit the composite, you can see how we have built a 3D set that includes perspective. If you alter the projection, just use the top view to realign the surface objects to match the new perspective from the projection. Before we move on, I'd just like to remind you that even though you're seeing the entire still being projected, always refer to the result view and look in the border area to see what you're actually framing for your final composite. In the second part of this video, we lock down the projections to the surfaces and bring the scooter back into a brand new environment. Comments, feedback, and suggestions are always welcome and appreciated. Thank you for watching, and please subscribe to the Flame Premium Learning channel for future videos.